Hey guys, what you're about to watch is my live walkthrough of a fairly tricky geometry question that I came across when I did the grade 9 tough paper 2 that I uploaded about a week ago. Now, I decided to do this because I realised that watching an hour and a half, an hour and 40-minute video might not be viable for some of you, so I decided to snip out this question to then present to you in another format. But let me know if this is something that's useful. Should I select individual questions and then show you how I kind of work through them, or is the kind of long paper format better for you? I will link the full paper in the description anyways, in case you guys want to have a look. But without further ado, I will let past me go through the question. There's always one question that just looks like it's going to give you a headache. So there are two touching circles, and it's always to do with circles. Anyways, circle 1 and circle 2. It's fairly clear that this over here is circle 1 and this is circle 2. It gives us the radii or radius, whatever you... Wait, no, the radii, so 5 and 4. That's how I know this was circle 1, because the radius was bigger, which means it has to be the bigger circle. C is the centre of circle 2, obviously. AB lies on the diameter of circle 1. Yeah, AB is going through the diameter. AB is also perpendicular to a line passing through the centre. Okay, this is actually a deceptively useful piece of information. AC and BC are tangents to circle 1 and pass through centre C. AC and BC are tangents. Yep, cool. Okay, yep, I've got it. Find the area of the triangle ABC. So this is a big triangle. Now, that does look really complicated, and almost always in questions like this, almost always, you're going to be using the fact that, well, a couple of things. The first one is this line made me, this line made me pretty happy. Because what they're trying to give you a hint. And it's very rare that the exam board are nice and merciful. But they're trying to tell you to do... Well, okay, it's a bit lower than that. To do that. And why is that? So you think, why are they giving that information? Well, this goes straight from the centre of one circle to the centre of the other, right? And they're touching. So this part of this is the radius of the first circle. That's 5 centimetres. This part is another 4 centimetres. So this total line is actually 9 centimetres long. So we have our first number. Now, if you remember how to do the area of a triangle, you need the perpendicular height and then the base. So we've actually worked out one of the two things we need. So just as a reminder, I know this sounds really sarcastic, but it's half base times height. But remember, the height has to be perpendicular. So we've actually already gotten one of the two things that we need. Super, super useful. Okay, so we've used that information and it proved very fruitful indeed. Now, the next thing I look at is this. Bear in mind, a lot of this information we have used, right? Like I have technically used the radii of both of these. The fact that it's the centre I have technically used because I said that this line was going through the centres of both circles. So all of this, like, we have used it, technically speaking. But those last two are really interesting. So what is important about tangents when you're talking about circles? Well, they're perpendicular, right? So, God, that was terrible. Yeah, let's undo that and actually give it a better go. There we go. Right angle and a right angle. And yeah, I've spotted another thing that we can do. This is pretty exciting. But the reason why I wanted to do that is we need to work out the coordinates of point A and B, which, as you can see, are the y-intercepts of both of these graphs, right? So it's the y-intercept, y-intercept. Once we work that out, working out the base is trivial. We just need to find the difference in the two coordinates and we're done. Which is easy. That's not too bad. But we do not... To work out the equation of these lines, we need the gradients, which we can and can't work out. Because we know that they're perpendicular, so we know it's the negative reciprocal, but we don't have any coordinates, which we do need to work out the equation of the line anyway. So we need to think about what we can do with the information we have. Just before we go on, it actually might be a good idea for me to label some of these points. So I'm actually thinking of two different ways of doing this. One way is to just work out this base here and do it from there. There's another way I'm thinking of, which I'm going to keep it to myself for now. Actually, no, I'm not. The other way is, because we've split this directly in half, we could just work out the area of the top triangle and then work out the area, and then just double it. So the question is, which one's more useful? Well, the fact that they're perpendicular is going to help in a second, because we need to use some trigonometry or Pythagoras to work out some of the other information that we need, because we don't have enough information at the moment, simply put. So if I work out, okay, so because we couldn't use the fact that we can't use the y-intercept by using the equation of a straight line, there is another way we could work out the length of this line. What I'm going to do is, if I look at this angle here, right, that angle is in this triangle, but it's also in this triangle, both of which are perpendicular. So what I'm going to do, I'm going to do something very clever. I'm going to work out the angle using this inside triangle, DEC. That angle will be the exact same as ADC. And what I'll be able to do is work out the length AD, which will be the same as the length of DB. That's probably the best way we can do it. Okay, so question is, what is this red length? Well, if you remember, it's just going to be the radius of the circle. So it's actually going to be 5 centimeters. So if I want to work out that angle theta, it is opposite over hypotenuse. So that means it will be sine theta equals opposite, so 5 over hypotenuse 9. Theta equals inverse sine of 5 over 9. Let's use our calculator. Change it back to the normal setting. Inverse sine 5 over 9 gives me 33. I'm just going to call it 33.7 degrees. I wonder if I should do a separate video on this question. This is a really good question. Once I've done that, I'm now going to get rid of this very carefully. Ooh, okay, I'm going to leave. I'm not going to push it. Now I have theta, so I'm going to get rid of that. It's 33.7, and I want the side AD. So let's just call it, I don't know, X again. Well, that's fine, right? It's opposite over adjacent. It's tan. So tan 33.7 equals opposite over adjacent. So X over 9. Because again, this is still perpendicular. I really think I should do a video on this one. This is a really good question. Which equals, well, I mean, I'm going to work it out on the calculator. I'm not going to do it in my head. 6.01. Do I want to keep it super accurate? Let's keep it super accurate. Let's do 6.01 centimeters to 3SF, which means the area of ADC is half base times height. Actually, no, I should label it. I'm getting too excited. All right, 6.01, which is going to be half 6.01 times 9. And that means the area of ABC is 2 times that entire thing. Beautiful. So 0.5 times answer times 9. Take that, double it. 54.1 centimeters squared to 3SF. What a question. Pretty good. Yeah, that was a pretty interesting question. But again, it's using the same kind of skills that we've used before. And yeah, and as you can see, all I did is I drew all of the information out and then made a decision. The hardest part there was seeing that there were 2 triangles that used the same angle. That I can see that being a bit of a problem because we don't really use that fact very much in GCSE maths, so you won't be used to using that fact.